in this problem it says let theta be an acute angle of a right triangle and find the values of the other 5 trigonometric functions. That's because we already have sine. So if we draw a triangle and we put theta in it, if sine is 5 over 13, we know the opposite side of theta is a 5, and we know the hypotenuse is 13. Using Pythagorean theorem here, we know that 5 squared plus something squared equals 13 squared. So 25 plus something squared equals 169. If you subtract 25 from both sides, you get 144. So this side right here must be a 12. So this triangle is not drawn to scale, obviously. But with that, we can find cosine of theta, because now we have the adjacent side. Cosine of theta is 12 over 5, or 12 over 13, because it's adjacent over hypotenuse. Tangent theta is opposite over adjacent, so 5 over 12. Then the other trigonometric functions are the reciprocals. So the reciprocal of tangent is cotangent, and that's just going to be 12 over 5. The reciprocal of cosine is going to be secant, and that's 13 over 12. And finally, the reciprocal of sine is going to be cosecant, and that's just 13 over 5. On problem 3, we're trying to find the exact values of x and y. If this is 60 degrees, this is 30 degrees. And we know this relationship exists for a 30, 60, 90. X is the short side, and whatever this is, we're going to double it to get the hypotenuse. So maybe what I would do is, I'd leave this x here, but I would make this a 2x. There's no need for a y there, because whatever the short side is, we double it to get this side. Then whatever the short side is, we multiply it by rad 3 to get this side. So this down here is rad 3x. But rad 3 times x gives us 6. So if we divide both sides of our equation here by rad 3, we end up with x equals 6 rad 3. 6 over rad 3. Once we rationalize this, we get, let's see, if we multiply by rad 3 over rad 3, we get 6 rad 3 over 3. That reduces to 2 rad 3. So this side right here must be 2 rad 3. Since this is twice this side, this is 4 rad 3. So x is 2 rad 3, and y is 4 rad 3.